Hello and welcome to the second of four videos I intend to include in my energy literacy project. And in this section I really wanted to delve into the methodology section, and in particular two challenges that I faced: collecting data and calculating my findings. So the first real challenge that I came across was actually determining the energy consumption in kilowatt hours of the gas shower. I found that it was fairly simple to actually calculate that value for the electric shower. For the gas it wasn't so easy because it's not a clean sort of calculation. I needed to convert what the gas meter was reading to kilowatt hours. So there was a couple challenges in and of itself to calculate that value. That took me about probably 2 days to figure out how I was going to accomplish this. So for the gas shower, I knew that the gas meter wouldn't be in kilowatt hours, but I didn't really know what the actual value represented on the gas meter. It didn't actually say on the meter. So after a bit of research I found out that it's hundreds of cubic feet of gas. And from there I took a reading before and after an 8-minute shower with the gas shower, and that was with all other gas using energy services in my household completely switched off, so that the only thing using the gas in the house was the shower. And I believe that gave me a reading of 0.13 hundredths of cubic feet. So that would have been 13 cubic feet of gas was used to power that shower. And from there I'd sourced a formula that my utility bill actually included on it, and used that to calculate the kilowatt hours of the shower. So that was how I accomplished that, but that did take me a while. That was about probably a solid day and a half of actually figuring out what the value on the gas meter was, and then how to calculate that into kilowatt hours. And then the second challenge that I had was with the electric shower, and that was because I was flip-flopping between two ways of calculating the carbon emissions of the electric shower. So originally for both the gas and the electric shower I was using carbon emission factors provided by the UK government, and the report, I think it was for businesses to convert energy usage to emissions so that they could report their greenhouse gas emissions levels. So for the gas that worked fine, because it was they gave me a natural carbon emission factor for a kilowatt hour of natural gas. So I just applied that to the kilowatt hour value that I had previously calculated for the gas shower. And originally I was using the same thing. The same report gave me a carbon emissions factor for the average kilowatt hour of electricity on the national grid, and I had been using that for a while, but then I realised that that actual value would definitely change by energy provider. So that led me to sort of look into, well, our current energy provider is Octopus Energy, and I looked into the fuel mix of how they generate their electricity, and that, to my surprise, was 100% renewable energy. So, using that, my electric shower would, it would emit zero carbon emissions, as it's all the electricity that it uses is generated from renewable sources. For comparative purposes, I used our old energy provider, SSE, because we only switched in the summer, and so I found they produced a fuel mix disclosure for 2019-2020, and I applied that to the kilowatt hours of the electric shower, and that's how I came up with the two values. So they were definitely two challenges that I think took me a combined 2.5 days to really properly figure out and sort of investigate how I was going to A, collect the data for, and B, calculate the values. So there were definitely challenges, but I overcame them. I definitely think that because it was my first time doing something like this, it was particularly rusty. I did make a fair few mistakes along the way, but the act of doing that and collecting that data and calculating those values has really made me more confident that I could replicate this sort of approach in the future for investigating my energy use